Hello and welcome to my video project. My name is Jack Vella, student number S3722070. So, starting off with task 1, here is my video project and a picture of me standing next to it. It's the shed in the back of the house. I actually measured the shed, which took a while because the measurements were quite large. I used a large tape measure and put them together. So the bottom was 10 meters by the width 6 meters, 3 meters high, and the roof was 2 meters tall. And here's some other measurements. Here's the approval email from task 1. Sure you approved it. All good. Task 2, you can see the frame-like structure. And my shear and bending force diagrams. So I did these both for a single resultant force of 13.33 because my student number ended in 0. So here's for the single force. You can see my calculations. And over here as well for the uniformly distributed force. But I actually slightly changed these calculations for now, as you'll see. So here's a drawing of my overall free body diagram on the roof, and for the uniformly distributed force. And you can tell, due to the symmetrical shape of the beams, only one side needs to be calculated for the first part of it. So I drew a more simple diagram just like this. You can see the uniform 13.33 kilonewton force on the one side of the roof. And then I thought about this and I thought, if you were to split that part of the roof, it would look like a sort of trapezoid, less of a rectangle, and I wasn't sure how to do the calculations for that. So instead of trying to do the calculations for a trapezoid, I thought I'd make it more simple by just removing the ends and making it so it's a rectangular beam, and that way I could do the calculations. Here's a quick summary of my maximum deflection and slopes. First I found the moment equation, then integrated that once and twice for the deflection and slope equations, found my what are they called, boundary points, point C and point B, subbed them in and got my equations for my slope, deflection and slope equations, as you can see here. After that I got my maximum deflection by letting it equal 0 and subbing in the x value. So I have my max here, which is negative 2.06 times 10 to the negative 4 meters. Then I went on with my maximum slope, similar thing, just letting it equal 0 again. The slope, subbing it into the slope equation, the moment equation equals 0, and there we go. Centroid was quite simple because, see, for this I didn't use just a singular beam. I used obviously the whole roof because it wouldn't make sense to just use one beam if I'm calculating the whole roof. These are in more detail in my work solutions, which I'll get to in a moment. Yeah, quite simple because they were simple numbers, which worked out quite well actually. Then I have my moment of inertia, just summarized here, maximum bending stress, and obviously here I've just got my moment of inertia and my y and my m, and I haven't really gone through it. So I'll skip past this, which is just summarized, and I'll go down here to my working out. So you can see here I listed how, if you look at it here, it's actually a trapezoid, the way the roof is sitting, but if you cut these dotted lines off here, you could just make it into a simple rectangle. And I adjusted the diagrams and the calculations for that. That's my force equations. Just to find the moment equation. This was my old shear force and bending moment diagrams, but I did change these up a bit to make it more simple. Maximum deflection and slope. I've already spoke about these. Same thing, boundary conditions, max deflection, maximum slope. Then the centroid calculations of beam, as you can see here, that's a singular beam I was working on, but now I put them together I've got my width and everything, my calculations. I've kept it 2D. My moment of inertia. I've included here the centroid and how that would work. Maximum bending stress, sorry. My moment of inertia, which I already had from previous calculations. My maximum bending moment, I actually just obtained from the maximum bending moment graph of 21.38. So I already had that, and all I needed now was my y. And that was simple, just by inspection, you could tell that it was only 1 meter. So I put them into the equation, and that's how I got my maximum bending stress. Maximum shear stress, a little bit more complex. I also got the max shear stress from the shear stress graph of 13.33, and then I did the partial cross-section area calculation for the moment of inertia for this, using the neutral axis. So you can see I got my A there equals 1, A dash, and my Y dash is 0.75. Then my calculation of B, the B was just a width of the cut, so it was 0.2 meters. Then I obviously put those all together and put them into the final maximum shear stress calculations. Got that. And this was, summing up this moment of inertia. And this bit down here, this is just some other stuff I was doing, thinking of other ways to do it, but didn't end up using it, so ignore that. And ended up getting it. Centroid was at 0.755. Then I moved on to maximum principal stresses. So I already had the X, which was 1709, and we knew the Y was 0, so it was just simply subbing them into the equation and getting 0 and 90 degrees for that. And then the in-plane shear stress of 0.007991 MPa, and then I just as well sub that into the equation and getting 0 degrees and 90 degrees. And here I just talked about how, although I did get 0 and 90 degrees and that's where they would fail, it's pretty unlikely in a real life situation you would actually get 0 degrees. It'd be a lot more likely you're going to get it an angle of 90 degrees in the roof, so you can sort of ignore the 0 degree one and say that the 90 degrees is the max. Thanks for your time. And one other thing I should mention is I did the calculations for the uniformly distributed load because I realized us doing the bending force diagrams, shear force diagrams, that this would have the maximum deflection and maximum slope and such, so I just did the uniform ones. Thanks for your time.